Curiosity rover on Mars, or the fusion reactor ITER, or the microchips which we use in our laptops. But behind all these engineering marvels, the driving force lies in the successful development of new materials, which can cater to the challenging conditions. And in this regard, Fred Kavli has rightly quoted, as we gain more knowledge about the materials and processes of the universe, it could open up benefits that we can't even imagine. And thus, we are here today to learn, to discuss, and to collaborate in the path-breaking advances in material science through ADAMS-22. My sincere thanks to all the distinguished guests who have kindly consented to grace the inaugural session today. We are extremely honored to have with us Dr. R. Chidambaram, former Principal Scientific Advisor, Government of India, with us as the chief guest for today's occasion. Dr. Chidambaram has also held the former post of Secretary, Department of Atomic Energy and Chairman, Atomic Energy Commission, as well as that of Director, Bhabha Atomic Research Center. Sir, your mere presence is a true source of inspiration to all of us. It is also our proud privilege to have with us Dr. R.B. Grover, Member, Atomic Energy Commission, and Emeritus Professor, Homi Bhabha National Institute, Mumbai, as the guest of honor for this occasion. Thank you, sir, for sparing your valuable time. May I now request to initiate the session, I request our chief guest, Dr. R. Chidambaram, to come up on the dais, and I request Dr. Vivekanand Kane, Director Materials Group BARC and Chairman ADAMS-22, to kindly accompany our chief guest. I request our guest of honor, Dr. R.B. Grover, to kindly come on the dais, and requesting Dr. Raghavendra Tiwari, Head Material Science Division BARC and Convener ADAMS, to accompany Dr. Grover. Ladies and gentlemen, as per our Indian tradition, we would begin the inaugural session by lighting the auspicious lamp. Through this gesture, we seek the blessings of the Goddess of Education, Mata Saraswati, before starting this important academic event. I request our chief guest and guest of honor to kindly proceed for lighting of the ceremonial lamp. I also request Dr. Vivekanand Kane and Dr. Raghavendra Tiwari to accompany our guests. I request you, sir, to kindly take up your seats on the dais. To begin the proceedings of the inaugural session, I now request Dr. Vivekanand Kane, Chairman ADAMS-22, to come forward to welcome the audience and speak about the conference.
Thank you, Paulini. Good morning to all of you who are present here at this auditorium. Greetings to all of you who are connected online with us. On behalf of the organizing committee of the DAE-BRNS International Conference on Advances in Material Science, ADAMS-22, I welcome our chief guest, Dr. R. Chidambaram, and our guest of honor, Professor R.B. Grover, and all the dignitaries, invitees, delegates, and ladies and gentlemen who are present here in the auditorium, as well as all those who are connected online. This conference is being organized by Materials Group Bhabha Atomic Research Center in association with the Indian Institute of Metals, Mumbai chapter, Materials Research Society of India, Mumbai chapter, and the Electron Microscopy Society of India. The conference is sponsored by Board of Research in Nuclear Sciences. We are fortunate to have here with us a galaxy of experts in the field of material science who are slated to deliver their talks and share the latest findings and trends in the field of materials research and development. There are 32 talks slated at this conference from the experts from India and abroad. 6 of these experts from abroad and several from different parts of India have traveled to Mumbai to attend this conference and be with us in person. Almost half of the talks are being presented in person at this conference that is being held in a hybrid mode. For the benefit of the attendees and delegates, we have provided all the relevant documents online on the website of this conference, including the program schedule and an abstract booklet as downloadable files. The abstract booklet has not been printed at all, and the printing of the program schedule too has been kept to a bare minimum. The conference ADAMS is being held in memory of late Dr. Sirikumar Banerjee. Dr. Banerjee had steered the research and development activities related to materials and specifically material science as Director Materials Group, and indeed he had spent his entire research career at Materials Group of BARC. The best tribute to Dr. Banerjee is by following the path he had shown us of creating excellence in our field of materials-related research, and therefore, to remember him now, this conference, where we shall share our latest research findings and debate on the current and future research trends in the field of material science. The last day of the conference, the closing session, is being held as Dr. Sirikumar Banerjee Memorial Lecture session. On his 76th birthday on Monday, April 25th, the family, friends, and colleagues shall pay homage to Dr. Sirikumar Banerjee, and the inaugural Dr. Sirikumar Banerjee Memorial Lecture, instituted by the Indian Institute of Metals Mumbai chapter, shall be delivered by Dr. R. Chidambaram and Professor Hamish Faisal. I am sure you all attending in large numbers, both at this auditorium and in the online mode, shall benefit from the expertise and latest research findings from the experts who are slated to deliver their talks at this conference. With support from different units of DAE and various professional bodies active in the field of materials, a conference dinner also has been arranged tonight at Acres Club, Chembur for the attendees who are attending from this venue. And I extend an invitation to all of you present here, all the delegates, organizers, and invitees to join us for the conference dinner tonight. On behalf of the organizing committee and on behalf of Materials Group Papa Atomic Research Center, I once again welcome all of you to this conference. Thank you.
Thank you, Dr. Kane, for the welcome address. Our sincere thanks to Dr. Ajit Kumar Mohanty, Director, Bhabha Atomic Research Center, who had kindly consented to grace the inaugural session today. However, due to some pressing official engagements, he could not be present in Mumbai at this day. Nevertheless, he has sent us his written message and requested that the same be read out in the session. For this purpose, may I request Dr. Raghavendra Tiwari, convener ADAMS-22, to come forward and read the message from Director BRC.
Good morning, all of you. And I read the speech of directors in quote. Good morning. I extend my greetings and warm welcome to all dignitaries, invitees, colleagues, and delegates gathered here, as well as to all online attendees to the DAE-BRNS International Conference on Advances in Materials, ADAMS-22, organized by Materials Group, Bhabha Atomic Research Center, in association with professional bodies. It is indeed my pleasure to address such a gathering of eminent professionals working in the field of material research and development. Human civilization has hugely flourished after the discovery of the metals and materials, and these have ever since been backbone for the major scientific and technological progress of the human race. Materials research continues to be a pivotal activity for the development of processes, systems, and technologies of the present and future, be it fusion energy, space technology, nuclear technology, communication, transport, to name a few. The nuclear reactor is particularly dependent upon the development of special materials capable of withstanding the demanding conditions prevailing within a reactor. R&D on materials for nuclear industry has therefore always been a thrust area of BRC. Activities were seeded right at the inception under the dynamic leadership of Dr. Ben Prakash, who helmed the Ultra Metallurgy Division. One of the earliest challenges faced was the fabrication of 50% of the fuel core of the Cyrus reactor. Many technologies, such as induction heating, standards for the non-destructive testings, vacuum meltings, were employed for the first time in the country to carry out the task. The outcome far exceeded expectations, with the produced uranium rods being able to withstand almost twice the specified radiation dose. There has been a no looking back since then, and the keys technology of several DAEs industries unit, which were subsequently established to scale up production, such as Nuclear Fuel Corporation, Complex NFC, IREL, UCIL, have been developed at Materials Group BRC. Amongst the succeeding leader, we must remember the significance of the contribution of Dr. P.R. Roy towards the development of nuclear fuel technology and Dr. C.K. Gupta for the development of metallothermic reduction process. It will be difficult to mention all of them, but we are certainly missing the larger than the life presence of Kumar Banerjee at this conference. He made immense contribution to multiple spheres of the materials research activity, not only towards solving the problem for DA, but also in creating facilities, nurturing research groups, and finding answers to some basic questions in material science. A strong advocate of the self-sufficiency, he launched an initiative for the development of an indigenous scanning electron microscope, a key tool for material research. And the first prototype is soon to be installed in an IIT for technical evaluation. Prior to commercialization, many in the audience would have associated with Dr. Banerjee in some capacity. Carrying forward his rich legacy would be the best tribute that we can be paid to him. With these few words, I would like to once again welcome all participants and take the opportunity to wish all the success of the conference. Thank you and Jai Hind. Unquote. Thank you.
Thank you, Dr. Tiwari. Our sincere thanks to Dr. A.K. Mohanty for sharing his thoughts on the conference and encouraging us as always. We express our heartfelt gratitude to Shri K.N. Vyas, Secretary, Department of Atomic Energy and Chairman, Atomic Energy Commission, sending his inaugural message to us in writing, since he also could not be present here today due to some last-minute changes in schedule. To read out the message from Shri K.N. Vyas, may I now request Dr. Vivekanand Kane, Chairman, ADAMS-22, to come forward and do the honors.
Dr. K.N. Vyas, Secretary, Department of Atomic Energy and Chairman, Atomic Energy Commission, has sent his message to be read out at this inauguration session of the conference. I read the message sent out by him. It is indeed a matter of great pleasure and proud privilege for me to extend a warm welcome and greetings to all the distinguished dignitaries, invitees, colleagues, delegates participating in the DAE-BRNS International Conference on Advances in Materials Science, ADAMS-22. It is heartening to see the galaxy of eminent materials scientists participating in this conference to deliberate upon the recent advancements in the materials research, in domain of knowledge and industry that has always been of special importance to the Department of Atomic Energy. In the broader sense, the development and usage of advanced materials is essential for the progress of any industry, but it has a special role to play in harnessing nuclear energy. With every new generation of nuclear reactors, the requirements of materials that have to perform in more challenging environments and enduring for longer life increases manifold. Therefore, Department of Atomic Energy has always put a special emphasis on the continued research and development of materials. These endeavors have been institutionalized and spearheaded by eminent leaders like Professor Brahma Prakash, Dr. C.V. Sundaram, Dr. P.R. Roy, and Dr. Sri Kumar Banerjee at BRC. As a reactor designer, I have closely worked with many materials scientists. During interactions with them, I started appreciating the subject a little more. And I confess here that whatever I know about metallurgy or materials science, these people have contributed significantly. Working in close association with these scientists, I learned fundamentals related to the alloy designing and the role of heat treatments in achieving optimized properties in a given material. Today, I recall my close association with Dr. Sri Kumar Banerjee. He was a simple and humble personality with a smiling face and a down-to-earth attitude. But he was a visionary who contributed in different domains of materials research activities of the department and left a lasting impact. A physical metallurgist, exceptional caliber in my opinion, he was synonymous with zirconium metallurgy in India. Though his pioneering work, he is known to the materials community world over. As DAE secretary, he had realized that the large facilities are essential for rapid progress of research in the country, and so is the collaboration of minds working in this field. He converted this realization into many international collaborations, which opened the access to large experimental facilities for the community of scientists and engineers of the department. These collaborations not only provided necessary exposures to the young professionals, but also instilled the confidence and ambition to the next generation leaders for setting up such facilities within the country. My association with the materials group during the early stage of development of materials for various projects gave me glimpses of the complexity involved in the selection and development of materials. Painstakingly doing generation and validation of data and then taking a decision on the future performance of materials is not an easy task. I am therefore now a firm believer in collective efforts for generation and dissemination of knowledge. I believe that the research and knowledge creation cannot be categorized into the boundaries of disciplines, administrative divisions, and hierarchies. Time has come for us to encourage the young professionals to break these barriers of formalism and freely interact with each other for furthering their research and its relevance. This, in my opinion, would be the best tribute to Dr. Sri Kumar Banerjee. I am confident that this conference will encourage such traits in the young professionals and further the cause of materials research. I wish fruitful interactions to all the participants and a grand success to the conference. Thank you.
Thank you, Dr. K, and our sincere thanks to Shri K. Vyas for sharing his thoughts on materials development in DAE. May I now humbly request Dr. R.B. Grover, our guest of honor, to kindly come to the podium and address the gathering.
Good morning, Dr. Chidambaram, Dr. Ken, Dr. Raghavendra Tiwari. I'm happy that this particular event is being organized, where along with discussions on materials, we also are remembering Dr. Banerjee. Dr. Banerjee and also the previous stalwarts who have guided the materials program in BARC and Department of Atomic Energy as a whole the last several decades.
Already messages from Dr. Mohanty and Mr. Kian Vyas have been read out, and they have provided glimpses of the personality of Dr. Banerjee. Let me add one more point. My association with him was quite close when he was Secretary DAE, because at that time I was also working in the DAE Secretariat. One point which immediately came out was that he always wanted to balance short-term and long-term planning. Sometimes it so happens one keeps on thinking long-term, and in that process forgets the short-term issues which are of importance. So he wanted a balance to be maintained in short-term and long-term perspectives of the Department of Atomic Energy. I thank the organizers to let me share some of my views here, and I like to talk about particularly what is expected from the materials program of the department in the coming years, in the new challenges which we face today. The call to reduce the emission of greenhouse gases has unleashed several structural changes in the energy sector, and all these challenges are really something which will throw up several issues for R&D by material scientists. For India, these challenges are more onerous than the developed countries, as we have to develop and decarbonize at the same time. In addition to development and decarbonization, there is a third challenge that is very peculiar. The developed world is responsible for occupying most of the carbon space, but they want developing countries to decarbonize along with them. And here I find that while many think tanks, many governments are sympathetic to the situation of the developing countries, all are not. So intense lobbying by interest groups is underway. One of the results of this lobbying is underestimation of the energy requirements of a country like India. The other is overestimation of the potential of renewables. And still another is to underplay the problems which arise by large-scale integration of intermittent renewables to the grid. The Government of India has announced that India will achieve net zero emissions by energy sector by the year 2070. Now, energy is used by households, by industries, for agriculture, businesses, transportation, and so on. And industry uses fossil fuels as a source of energy and also as molecules for reduction, or in many cases, feedstock. While electricity can provide energy, the feedstock can be provided by hydrogen or its derivatives, such as ammonia. To achieve net zero, India needs many-fold increase in electricity generation, and estimates by us point out that we need about 15,000 kilowatt hour to 18,000 kilowatt hour per capita per annum to become a developed country with a very high human development index. Taking 16,000 kilowatt hour per capita per annum as a benchmark and assuming a population of 1.5 billion in 2070, it translates to a generation of 24,000 terawatt hour annum. And this we can compare with 1,600 terawatt hour per annum, which India is generating at present. If we leave the effect of pandemic, that these 2 years, the CAGR for the last 10 years has been around 7%. And if we keep on growing at this CAGR, this number is achievable. But this number is very large. And part of this electricity will be used as in electrolyzers to produce hydrogen. Hydrogen and hydrogen derivatives will then be used by industry, aviation, shipping, etc. One day we may have high temperatures nuclear reactors or solar thermal, and they will make it possible to produce hydrogen without first producing electricity. And even in that case, one can think this number as equivalent electricity, if not just electricity. While we should harness the full potential of renewables, the full potential is not sufficient to provide this large quantity. So we have to look for other sources. And amongst other sources, nuclear is most important. Of course, we also have to continue to harness coal along with carbon capture and use. As all of you know, pressurized heavy water technology in India is now fully indigenous, and that is not just reactor technology, but also front-end and back-end technologies. India operates uranium mines, fabricates fuel, manufactures all equipment and components for the PSWR system, reprocesses spent fuel, and manages all type of nuclear wastes. And in all this development, material scientists have played a very, very good role in the past decades. And now we are embarking on constructing 700 PSWRs in a fleet mode. And this particular reactor can be the workhorse for the expansion of nuclear installed capacity in the country. One pertinent issue is the availability of uranium to fuel reactors. Domestic uranium supplies are not enough, and import of uranium is now possible after the relaxation guidelines by Nuclear Suppliers Group in 2008, which facilitates import of uranium from other countries, and this is something which we are already doing. The issue of disruption of fuel supply was also addressed during the negotiations leading to relaxation of guidelines by nuclear supplier groups. India has a right to have a strategic reserve of uranium. In the case of nuclear fuel, one can have a reserve for several years without any difficulty. It could be 5 years, it could be 10 years, or the lifetime of the reactor. Exact number of years have to be decided based on how much inventory carrying cost one is willing to pay, and this will be based on economic considerations. Estimates have been made by a couple of academics with regard to how much gigawatt of installed capacity based on nuclear will be needed by India. And numbers are very large. They are really staggering. One particular estimate I would like to quote here, Professor Amit Garg of IIM Ahmedabad. He's working on a project in this area, and his estimate is 155 gigawatt by 2050 has to be the installed nuclear capacity in the country. And similar estimates are there by CEEW, which is the think tank based in Delhi, Center for Environment, Energy and Water. So what we need very large nuclear capacity. And to achieve that kind of capacity, we have to develop the next generation of technologies that enable siting of reactors near population centers. And here, fast reactors and molten salt breeder reactors have the potential of playing that particular role. For developing these technologies, particularly MSBR, that is molten salt breeder reactor, extensive development work needs to be done in the area of materials. And that is where material scientists become very important. Working on these areas will be the best tribute to Dr. Banerjee, who spearheaded the materials program in BARC for several decades. In addition, let me come to one more topic, and that is the nuclear community has to manage the issue of perception. It is not perception about safety, it is perception about the cost of nuclear energy. About safety, everyone acknowledges that Atomic Energy Regulatory Board is doing a good job, and we have managed to ensure safe operation of the reactor. The common perception is that renewable is cheap. Here, I like to remark that one has to look at the total cost and not just the cost of generation. Between the generator and the consumer lies the transmission and distribution system. The system manager has to balance supply and demand at all times, even when the sun is not shining and the wind is not blowing. And this management adds to the cost. Renewables, due to intermittency, result in manifold increase in the system cost, and this has to be explained to the public. And estimates have been made about this cost, both by think tanks, academics, and also by the Forum of Regulators in India. If we include system costs along with the cost of generation, nuclear is competitive because it hardly has any system cost. So earlier, we were managing safety perception. Now we have to talk about the cost perception as well. Thank you.
Thank you, sir, for sharing your valuable thoughts on the recent development in nuclear energy sector in our country and inspiring all the material scientists. It is my honor now to humbly invite our chief guest, Dr. R. Chidambaram, to address the audience as well as officially inaugurate the conference. Please, sir.
Dr. R.B. Grover, Dr. Vivekanand Kane, Dr. Raghavendra Tiwari, Dr. Paulami Chakravarti. I mentioned your name. Distinguished participants, both in person and online, and friends. Firstly, I'm very happy to be able to participate in the inaugural session of this conference and also later. And I'm grateful to Dr. Vivekanand Kane for this invitation. There have been very famous metallurgists who have been involved in our nuclear energy program, N.K. Rao, Balram Murthy, C.V. Sundaram, R. Krishnan, P.R. Roy, and many others. And of course, metallurgy has now evolved into material science. And there are other people who are other departments in atomic energy which have which also played a major role in the development of material science. As has been mentioned, materials are central to all technology. In fact, that's going to be the title of my talk on the 25th. See, among them, there are materials of scientific and functional interest. There are materials with technological possibilities. And if you count all of them, they range from biological macromolecules. You all remember Venki Ramakrishnan got the Nobel Prize for solving the structure of ribosome, most complicated structure so far solved using the technique of X-ray diffraction. And you know, as I was mentioning in some other context, he got the Nobel Prize for chemistry. And the material he studied was biological, ribosome. And the technique he used was physical. So we see the one more example how the boundaries between disciplines are kind of going away. And material science is one such attempt is to bring metallurgists, physicists, chemists, and now you can't exclude biologists from anything. They are also getting involved in this. Then there are electronic materials, not only semiconductors, but many others, like you have, bulk acoustic wave resonators, surface acoustic wave resonators. They all use strontium titanate. Energy materials, both nuclear, we are familiar with all the materials that are involved here, renewables, they are going beyond silicon to perovskite and other materials. Other technologically important crystals. And there is a continuous growing range of nanomaterials. Nano is a kind of a catch-all. Can put the prefix to anything, and then you will find somebody or other has worked in that in that area. We also now talk of sustainable materials. You can't go on exploiting materials without leaving enough for future generations, unless of course it's a renewable material. I thought in this conference proceedings there will also be presentations on many emerging materials, like high entropy alloys. This is becoming a very important system now, formed by mixing maybe 5 or more elements, because these are more stable at elevated temperatures. And they become suitable for applications for which other materials were difficult to find, like jet engine applications. High entropy alloys are also considered a promising option for advanced nuclear applications, with a wide range of possibilities. Of course, the work on this is just beginning to optimize high temperature, mechanical properties, radiation, and corrosion resistance. I'm very happy to notice that there will also be presentations on artificial intelligence-based techniques used in materials development, software paper and computational thermodynamic approaches. Of course, there are now a wide variety of experimental techniques available now to study materials, also use them to develop and design new materials. And I'm sure the latest trends and development in these techniques will be discussed in this conference. One talks of key enabling technologies for development, for accelerating development and strengthening innovation. And if you go through them, you will find that in general, they are all dependent on material science and materials development. There are also what are called frontier technologies, which take advantage of digitalization and connectivity, like artificial intelligence, I mentioned, also 3D printing, robotics, drones. All these technologies are also strongly dependent on materials development. New materials will continue to be needed in the future, and also applications will also grow, matched by appropriate processing techniques. One of the very important areas where it will grow apart from nuclear is renewable energy and storage. Mentioned about perovskites. What about storage? Because whatever you say, renewable energy is intermittent. So it has to become a power source. lithium-ion batteries. But the government has started a very big program on a tender rather. The people working in it, like Sikri and CSIR, lithium-ion battery 100 crore plant coming up in Chennai by Sikri, CSIR. We need materials for lower weight transportation, improved composites, for example. And in this field of medical technologies and biological functionalization, for example, bone and tissue replacement, it's going to be a very, very important field as we go into the future. And then Grover mentioned about managing climate change. And these are going to require materials of various kinds, including for carbon capture. Then we should not forget, I talked about sustainable materials development. We have also to give a lot of attention to recovery and use of scarce resources. I think nuclear is one good example. For example, closed nuclear fuel cycle. Those guys who favor open nuclear cycle throw out a valuable material like plutonium as waste, whereas we recycle. Of course, we take out so many isotopes, cesium and all that from there. And already we have serious problems in auto waste, electronic waste. What about solar panel waste? One day it's going to be a big, like the automobile waste problem in the US, you will find junkyards outside every city, full of old. But when I was there, my second-hand car had a small accident, the bonnet got. He said, don't worry, we'll go to the junkyard. And he found an exact car, put the panel back here. But that's not the reason for keeping the junk over there. You have to recycle auto waste. My friend was telling me, Captain Mohan Ram, there are 180,000 tons of aluminum that is there in every year discarded cars. So we have, if we have to sustainable development for generations, we have to recycle. And hence recycling has to become a very important part of material science. And look at the amount of mobile phones which are being thrown away. You can call it as part of e-waste. As I briefly mentioned, artificial intelligence and machine learning techniques are being adopted and applied in every field, and materials development is no exception. And AI and ML have the potential to accelerate the development of new materials, particularly when you have a choice of materials in developing a special alloy, like I mentioned, for example, high entropy alloys. That, of course, the potential of AI in material science extends well beyond the discovery of new substances and compositions. Those can come in utilization and so on. Program of the conference, Dr. Kane, is very well designed, and I'm sure there will be excellent presentations. I'm also confident that the discussions will lead to new collaborative efforts. So one of the most important things is the new collaborations that can emerge from here. And I myself, when we started work on positron annihilation in Kosikostas, it came not from listening to a lecture, but looking at a poster. In the poster, you can sit and talk, stand and talk with the young man who is displaying the poster. So, see, I have not mentioned anything about Dr. Shikumar Banerjee, because I'm going to give a full lecture in his honor on the 25th. But as you all know him, he was a very dear friend. And you know, I've always said, if you talk to Shikumar Banerjee, he could talk on any subject. And he could even be mistaken for a physicist. His knowledge was so extensive. Maybe I'll mention it. So, wish you all the well for your this conference. Topic is absolutely on time. Advances in material science. But then there is a continuing topic. Advances in material science will never stop. Thank you very much.
Thank you very much, sir, guiding us, for motivating us, and giving a wonderful perspective on the new materials development across the entire length scale. Let us thank the chief guests once again. It is time now to release that special issue of the Transactions of Indian Institute of Metals, about which Dr. Kane had already mentioned in his welcome address. To do the honors, may I once again request our chief guest to kindly come forward and release the special issue. I also request our guest of honor, Dr. R.B. Grover, Dr. Vivekanand Kane, and Dr. Raghavendra Tiwari to join the chief guest on this momentous occasion. Thank you, sir. You may kindly take your seats back. With this, we have now come.
Just to mention about this special issue of Transactions of Indian Institute of Metals, this April issue of 2022 is in memory of Dr. Srikumar Banerjee. There are 22 articles, technical articles published in this. Most of them are by his close colleagues, collaborators, and youngsters who had worked with him. This issue is available online at the website of the Transactions of IM. Anyone who wants to refer to these articles is welcome to do so by visiting. This is available for a period of 45 days, free of cost to everyone. Thank you.
Thank you, sir. So we have now come towards the end of this inaugural session. And now I would like to request Dr. Raghavendra Tiwari, convener ADAMS-22, to come forward and propose the vote of thanks.
Good morning to all of you, and welcome again. So, on behalf of the member of the Materials Group, I am glad to standing here to express the vote of thanks. And a special thanks to our chief guest, Dr. R. Chidambaram. Without his constant support, it is not possible to hold this conference, sir. My heartfelt gratitude for his critical and crucial supports. And I want to take this opportunity to thank Dr. R.B. Grover also, who, in spite of very busy schedule, taken some time off to come and grace this occasion. I know he's coming yesterday very late night from Hyderabad, but he made it in time in this occasion. Thank you, sir, for giving us time. And needless to say that we require the blessing of other patron, our Dr. K.N. Vyas, Secretary DAE and Director BARC, Dr. Mohanty, for giving support to surmounting many barriers we were facing all along during the course of preparation of this conference. And we wish to thank Director BRC and our chairman for giving the message, though they could not present because of that present need outside somewhere. And I also want to thank Director BRC for sponsoring for the high tea for the today. Thank you, sir, for all your kind support. And this occasion I want to thank BRC and DA staff who worked tirelessly to arrange the many documents, including visas from the various government departments. Nearly hourly basis updates were given. And we are very thankful for their extraordinary efforts, because of which we could arrange most of things in time. I take this opportunity to thank all of them, and all of delegates particularly came from a different part of the globe as well as from the country after coming out of the, because in the time of the pandemic, fear timing, people are not traveling, so they have taken extraordinary pain to come here. Thank you very much. And we wish you very safe and fruitful stay here and safe journey back. And this record time. This I wanted to keep on the record time. Thank you very much, Mr. Sabra, for financial support. I would also like this opportunity to thank Beacon Analyticals. Now they have changed their name. So, Dr. Anand for giving much support for the dinner for this conference today. The guidance provided by Professor Amish Roger, Professor Chattopadhyay, Dr. Professor D-BRNS, and Dr. G.K. Day, Professor Rafi Banerjee, throughout several virtual meetings, the logistics of the conference are gratefully acknowledged. Behind the success of the conference, there are tireless efforts of various organizing committee and volunteers who work almost round the clock to make this conference successful. I want to thank Dr. Raj and his team for making wonderful hall arrangement in a really new concept of a hybrid conference, which looks easy, but it is not. Take my word for it, because that same extending same feeling to the person sitting in the net to the hall is not an easy task. Thank you, Dr. Rajagiri and your team. I want to thank Dr. Kinshuk Das Gupta and Dr. Santosh Kumar and their team for kindly executing for the publication. There are several kind of different set of publication, and till last minute we were not sure what to do and what not to do. So they have pulled it up all the way in time. Thank you, both of you. I also want to thank Dr. Naik and his team for managing this web management. The website generation is the task from where the what his work status. And then every minute he had to update. So we very carefully cross-check each and every point that all information going in the web is correct. Because once it is gone in the web, it is very difficult to restore back. So he has done it very meticulously. Thank you, Dr. Lai, for your efforts. And Dr. Rajiv Kapoor, who put together all the programs till the last minute adjusting, turning things upside, making the program. Every 10 minutes he was updating the programs. So thank you for Rajiv Kapoor for that. And needless to say, no conference in India is called a good conference if the food of the conference is not up to the level. With this shoestring budget, managing this aspect is not an easy task. And I know the kind of sort of thing our catering team has gone, particularly Dr. Ajit Ghosh, has seen many times, but always with a smile, he faced the problem and came up with a solution. So thank you, Dr. Ghosh. And managing the conference without a very meager finance source is a sort of a find which has been perfected by Dr. Ramesh and his team. So I do not know how they are pulling up, but so far we have kept everything. So thank you, Dr. Gupta, for that. And the one another aspect you might have seen, Dr. D.K. Singh and his team, Dr. K.K. Yadav, they managed the transport issues, accommodation issues, almost with a very little support from us. So thank you, Dr. Singh, for doing a flawless job here. And last but not the least, I personally want to thank Dr. Vivekanand Kane and Dr. Ashok Arya for taking nearly all the responsibility of my shoulder. I may be the only convener who slept 8 hours straight without any disturb a night before the conference started. Thank you, Dr. Kane, for that. So in the end, on the application of all those whose name I could not take due to the paucity of time. And I want to thank all of you for selflessly working for the success of the conference without anticipating anything in return. In my opinion, and in all our opinion, you are the true hero of the success of the conference. Thank you very much.
Thank you, sir. That concludes the inaugural session for today. You all are now invited for the high tea, which will be served at the dining hall of the center. And we are very, very grateful to Dr. A.K. Mohanty, Director BRC, for hosting the high tea today. Sir. The first technical session will begin in the same auditorium sharp at 11 a.m. So you all are requested to assemble here 5 minutes prior to the start of the session. The invited speakers may kindly note that you can collect your registration kits from a separate counter at the registration desk. For the high tea, once you move out of the auditorium, you will find the dining hall to the right of you, and volunteers are there to guide you to the dining hall. So thank you for joining us, and kindly have your tea and come back soon, because there are lots and lots of interesting materials coming up your way. Thank you.